In this video, I'm going to introduce you to some new notation that's going to look a little bit familiar, but just it's got some slight differences, and we'll begin on our calculations. So we're going to have an overview of what is called stage 2 calculations, but in this video, we're really just talking about the degrees of freedom calculations. So when we have a factorial design ANOVA, we have two stages. The first stage is identical to what you did last week. It's identical to the one factor ANOVA, where we separate the variance into three different components: the sums of squares total, the sums of squares between, and the sums of squares within. So that first part is the same. But in the second stage, we're going to take that sums of squares between, and we're going to split that out into three components: for factor A, factor B, and for the interaction of A times B. So we take the sums of squares between and separate it out into three different components. And this is what it looks like if you need a visual. In stage 1 is a regular ANOVA. We take our total variance and we divide it into between treatments variance and within treatments variance. And then in stage 2, when we're looking at the separate factors in the interaction, we separate factor A variance, factor B variance, and an interaction variance, easy for me to say, from the between treatments variance. So this is a new chart, and this is right above this video, so make sure that you've downloaded it and have it at the ready. This chart will make your life infinitely much easier. So you'll recognize it as having the same types of things as a single factor ANOVA, but the items that are grayed out here are what are added: factor A, factor B, and the interaction. So in stage 2, we are not calculating sums of squares for factors. You can breathe a sigh of relief. You can say, I'm not doing that for those individual factors. I have provided for you the formula in case you're interested, but we're certainly not doing this. So just know that basically you're going to be given the sums of squares for the factors this week. So let's talk about the notation as it applies to a factorial design. K is still the number of treatment conditions, but in a factorial design, that is equal to the number of cells in the matrix. So for example, if we have a 2 by 2, we have 4 different cells, so K is equal to 4. So K is the number of boxes, it's the number of cells, the number of treatment conditions. Lowercase n represents the number of scores in each of those individual cells. So in every treatment condition that we just talked about with K, there's a number of participants or number of scores in each cell. That's the lowercase n. Let's review how we did degrees of freedom from stage 1. Degrees of freedom total was n minus 1, the total in the study minus 1. Degrees of freedom between was the number of conditions minus 1. And the degrees of freedom within, we could find it one of two different ways. We could take the total n and minus the number of conditions, n minus k, or we could just add up the degrees of freedom that were in each cell. So we'll still do that for this factorial design. But in stage 2 for this lesson, we have some different degrees of freedom that we're going to talk about. So this is what you're going to want to make sure you have in your notes, that for degrees of freedom A, we take the number of rows that there are minus 1. For degrees of freedom B, we take the number of columns that there are minus 1. And the degrees of freedom for the interaction is a little different. We're going to take the degrees of freedom between, we're going to subtract the degrees of freedom for A and degrees of freedom for B. And that's how we find degrees of freedom in the factorial design. So let's take a look at an example. A public health researcher is interested in the impact of diet and exercise on weight loss. So 48 obese patients were studied, and we have 8 people in each condition. We'll look at the conditions in just a minute. We're going to find the degrees of freedom for total, between, within, factor A, factor B, and the interaction. So let's look at what we mean by condition. So as we look at the grid down here, I see a 2 by 3 factorial design. The first factor, factor A, is exercise. So some people in the study did no exercise, and some people did 30 minutes a day of exercise. So we have 2 different levels of people in this study in terms of exercise. And then we have 3 different levels for diet. We have a 1,200 calorie a day diet, 1,600 calories a day, or 2,000 calories a day. So people could have been in one of 3 different diet conditions. When you put these 2 things together, factor A and factor B, it equals 6 different conditions. So we have a condition of no exercisers at 1,200 calories. We have a condition of no exercisers at 1,600 calories, etc. Remember, we have 8 in each different group. So this gives us enough information to find all of the degrees of freedom. Let's give it a try. Let's start with our degrees of freedom total, which we determine by n minus 1. We had 48 in our study. Minus 1 gives us a total degrees of freedom of 47. Now we have our degrees of freedom within. And there's a couple different ways to figure this out. You could just add up all the degrees of freedom in each cell. I think it's much easier just to say n minus k. Our n was 48. The number of conditions we had was 6. It was a 2 by 3 grid, so it was 6. So our degrees of freedom within are 42. Finally, our degrees of freedom between are going to be equal to k minus 1. And we had 6 treatment conditions minus 1, which gives us a degrees of freedom of 5. So let's take a look at this on the grid. And here I've added in the degrees of freedom between, within, and total. The next thing I'm going to do is I'm going to take that between treatment degrees of freedom and split it out between factor A, factor B, and the interaction. We'll start with the degrees of freedom for factor A, which is the number of rows minus 1. We had 2 different rows. We had 2 different exercise conditions. So I'm going to say 2 minus 1 gives me degrees of freedom of A of 1. Degrees of freedom for factor B is going to be equal to the number of columns minus 1. We had 3 different calorie groups, so 3 minus 1 gives us degrees of freedom for factor B of 2. And then the degrees of freedom for the A by B interaction is going to be our degrees of freedom between from stage 1, which was 5, minus my degrees of freedom for A, 1, minus my degrees of freedom for B, 2, gives us a degrees of freedom for the interaction of 2. 5 minus 1 minus 2 gives me 2. Let's put this on the chart. All right, now I have them all listed on our chart, as I hope you do too. And just as a reiteration, the numbers that are in red add up together. 5 plus 42 is 47. And these numbers in blue all add up to this between treatment of 5. So if you've got these numbers all adding up, you're in good shape. Let's take another one. A social psychologist explored time spent on appearance management by gender and situational context. With an N of 30 individuals, 5 were in each condition. We're going to find all the degrees of freedom that we did before. But before we do that, let's talk about the levels that we have. So for factor A, we have 2 levels, male and female. And for factor B, the situational context, we have romantic date, group date, and friends. And so how many conditions do we have? How many groups do we have? Well, we have 2 by 3, which is 6. We have 6 different conditions. One condition would be the number of times spent on appearance by males on a romantic date, that would be here, or males on a group date, males and friends, etc. So let's do the first set of degrees of freedom for stage 1. So I'll start with degrees of freedom total, which is equal to n minus 1. So 30 minus 1 gives us a degrees of freedom total of 29. Next, I'll go to degrees of freedom within, which, as a reminder, we could add up the degrees of freedom for each individual group, or we can say n minus k. We have 30 people in the study. We had 6 different groups. So our degrees of freedom within is 24. And finally, for degrees of freedom between, that is k minus 1. We had 6 groups. Minus 1 gives us degrees of freedom between of 5. So those are our degrees of freedom. And here they are. You'll see very clearly that 5 plus 24 is 29. For stage 2, we're going to take this 5 degrees of freedom and split it up between factor A, factor B, and the interaction. Let's start with our degrees of freedom for A, which was the number of rows minus 1. We had 2 different rows for male and female, so the degrees of freedom for A is 1. Let's do the degrees of freedom for B. We had 3 different columns, minus 1. So degrees of freedom for B are 2. And the degrees of freedom for the A-B interaction, which is equal to our between degrees of freedom 5, minus 1, minus 2, for degrees of freedom for the interaction of 2. Let's put those on the chart. And here they are. So we had factor A, 1 degree of freedom, factor B, 2 degrees of freedom, the interaction 2, and if you add those up, they equal to 5. Hopefully this gives you a good sense of how to do degrees of freedom. In the next video, we're going to move on with our calculations.